Now this is basically this is basically a diagram portraying the overall picture of data mining. Okay, let's start at the top. We have data mining techniques. Okay, there are two different styles of data mining. There's descriptive data mining and there's predictive data mining. Descriptive data mining typically involves techniques known as clustering, grouping people together, association, associating certain patterns, and sequential analysis, determining what follows. In predictive data mining, we have classification, which includes using techniques as decision tree analysis, rule induction, neural networks, and nearest neighbor classification. And the other style of techniques that's used are regression techniques. Now let's take a look at predictive data mining. This is what we have in our database. This is what we know. We know that John, Vicky, and Mike are honest people. We know that Wally, Waldo, and Barney are crooked people. The prediction, data mining will be able to predict for us based on the fact that John, Vicky, and Mike, based on us knowing that these three people are honest, predictive data analysis will go and take a look at the unique characteristics of these three people. So we see that all three people, although they have different hats, they all have round eyes and a smile. Let's take a look at decision trees. Okay, this is the data that we have in our system. We have height, hair, eyes, and class. So we have 8 profiles in our data. We have short, blonde hair, blue eyes. We have tall, blonde hair, brown eyes. We have tall, red hair, and blue eyes. We have short, dark, and blue eyes, etc. All these 8 profiles fit into a specific class, either class A or class B. Now we're going to go ahead and develop a decision tree. We know that we can identify, based on the hair color, someone with dark hair, if they're short and blue-eyed, tall and blue-eyed, or tall and brown-eyed, they'll fit into class B. If they have red hair and they're tall and blue-eyed, they'll fit into class A. If they have blonde hair, we're not finished our tree. Because for the blonde hair, within our profiles, we have short and blue-eyed fit into class A. Tall and brown-eyed fit into class B. Then again, tall and blue-eyed fit into class A, and short and brown-eyed fit into class B. So this doesn't completely classify blonde-haired people just yet. We need to do another branch on the tree. The next phase will be to look at the eyes. We'll say that blonde-haired people that have blue eyes, whether they're short or tall, fit into class A. Blonde-haired people that have brown eyes, whether they're tall or short, fit into class B. Now we have a completed decision tree. Because all 8 profiles appear at specific points or nodes. At each node, all classes or all profiles are in the same class. Everything fits into an A or B. So this will help us predict, using this classification system, what profile fits where. Okay, so we know that the dark-haired always fit into class B. The red-haired always fit into class A. But the blonde hair, depending on the eyes. If they're blue eyes, they fit into class A. If they're brown eyes, they fit into class B. Let's take a look at rule induction. Here, with rule induction, we try to find rules of the form. Okay, we always have an if-then analysis. Okay, what follows? If will be on the left-hand side, and then will be the right-hand side. This is the reverse of a rule-based agent, where the rules are given and the agent has to ask. Here it's the opposite. Here the actions are given, and we have to discover the rules. Now what we do is, we apply two concepts. We apply prevalence, which is the probability that left-hand side and right-hand side occur together. Sometimes it's called support factor, leverage, lift, whatever. But we're gonna apply the prevalence. And the next concept we apply is predictability, the probability of right-hand side given left-hand side. If we have left-hand side, then the predictability of right-hand side. Okay, sometimes called it confidence or strength, but that's the general concept. Let's take a look at how this works. Okay, we're going to try to associate rules using market basket analysis. Okay, so if we're going to have, say, refrigerated dairy milk for supper, okay, then we'll have carbonated soft drinks, okay? Now the prevalence of dairy milk, of refrigerated milk, as it relates to carbonated soft drinks is let's say 4.99%, just for example's sake, okay? And then we'll say that the predictability, if we know left-hand side, if we know dairy milk refrigerated, we can predict that we'll have also soft drinks carbonated, let's say 22.89%. Again, we're just going to use these numbers for example's sake. Okay. Same with, let's say if we have a pasta for dinner. How prevalent is it that we'll also have canned soup, and how predictable is it that we'll have canned soup? Let's say pasta and then ready-to-eat cereal, or cheese slice and ready-to-eat cereal. Again, we're going to apply the prevalence. How prevalent is it to the left hand? Let's say how prevalent is the right-hand side as it relates to the left-hand side, and how predictable are they? Why would we do this? One reason we do this is, let's say, coupons and discounts. Okay, we're not going to give discounts on two items that are frequently bought together. We'd rather use the discount on one to pull the other, right? Let's go back to the example of the bike and the helmet. If we know that they're always bought together, we can say all we need to do is give a discount on the bike, and we'll pull in the full retail value on the helmet. Product placement. We can offer correlated products to the customers at the same time to increase sales, right? You ever see a if you ever see an ad, a store flyer, saving sales of the week, they'll have a package, right? Why would they do that package? Because they know that all of these products are bought together, and by offering a 5% discount on the overall package, so they're really only offering, let's say, a 0.5% discount on each product. But because they're always bought together, the customers will tend to buy the whole package. Timing of cross-marketing. Right, this is typical. Right, you buy a camcorder or VCR, you buy a right, and it comes along with that purchase comes, let's say two free flashcards. Now, the store that sells you those camcorders know that the flashcards are going to last you maybe 2 or 3 months. So we go ahead. So in 2 or 3 months, you'll get in the mail, hey, would you like to buy another flashcard? Discovery of patterns. People who bought XYZ, but not any peer, bought W over half that time. Let's take a look at clustering. Clustering is the art of finding groups in data. The objective is to gather items from a database into sets to common characteristics. Now, clustering is much more difficult than classification because the classes aren't known in advance. We don't have any particular training on what these classes are. The technique that's typically used is unsupervised learning. Thanks so much, guys. I appreciate it. Now we're going to open the lines for questions.